All right, everybody, welcome back to Binary Adventure. So as promised in the last video, I'm now going to go over how to just look at some basic information about the binary that we're working with here. And in fact, arguably, I would have usually done this first, but I know that some people who, were scrambling around looking for tutorials on Radare, they may just need to dive right into some disassembly real quick. So that's the reason why I kind of did the exciting stuff first, so to speak. So, but this is still exciting. We're going to be looking at a lot of information that we can see, not necessarily code-related information, doing like a basic sort of once-over on the binary using Radare's tool suite. So, for example, some of you, if you've ever done any Windows analysis, may be familiar with a tool called PE Studio, and it's used by a lot of malware researchers to see things like the imports, the exports, the architecture of the binary, things like that. So we already covered imports and exports in the last videos, but let's just see what else we can find out about the binary. And then there's also a string utility too, which is pretty useful as well, and we'll take a look at that probably in the next video. So what I'm actually going to do, and I'm going to leave Radare. So we don't actually need to be inside of Radare to do what we're going to do. You can do it from inside Radare using those I commands, but I'm going to go ahead and leave Radare. So I'm going to hit Q again, and then type Q, and I'm going to exit. So we're out of Radare now. And we're going to look at that letter frequencies program once again, but this time we're going to use a program called Radare2, or Radare binary 2, basically, right? And we're going to run that program, and actually the first thing we're going to do, we're going to man page it, because I want to show you how to get information in case you have a question that's not answered in the video. So we go out here, and it basically gives us a list of things we could do. So we could show information about a specific address, as shown right here. We could list sub-binaries. We could set an architecture. We could set bits. So you could actually edit the file with this, not just view it. And so let's just say, so show binary info. So you could see here how it says I, capital I, and R2. So like I said, a lot of these commands, or all of them, can actually be called from within Radare, but we can do it outside of Radare using this utility, which could be useful. You could output the data in JSON. There's a lot of things you could do with this. You'll be able to get strings from this. You're going to be able to get imports and exports, the header fields, lots of info here that you have access to. So let's just go ahead and let's go back up and see what we want to do here. So we're going to do dash capital I for show binary info first. Okay. So we're going to do rab2 dash capital I and then letter frequencies. Okay. Check this out. So architecture is x86. The size is 11,004 bytes. Binary type ELF, 64-bit. It has a stat canary, so this is useful for security analysis, right? ELF64 is the class. And then we have, it's little endian. The language it detected was C, that was used to program this binary. Here we have the machine. We have operating system for Linux. NX true, another very useful thing for security. A non-executable stack is set. And then pick is also true. Position independent code. So it'll load and randomize the base address, right? So those are all very useful things to know doing security research, because maybe we want to change some of these things. Maybe we want to turn NX off, or you want to turn pick off, or something like that. So you can get that general information by just doing that. So let's just do RA-bin2 without anything passed and see what happens. So what it does is it just gives us a help. Let's see what else we want to do here from our menu. let's do, so you can get the address of main here. You can, so if this was C++, you could look at constructors and destructors. You could look at classes. Let's look at the header. Let's look at the header fields, okay? So the header fields is going to be an abbreviated version of what, like, you know, a header parsing program like O10 editors templates will do, or again, like PE Studio or something will parse out, you know, PE file headers on Windows. This will do the same thing. So let's do rabin-h and then letter frequencies. So it's giving us the version, the entry point address. So let's do -m to get the start address of main. So that's the start address of main right there. And then I believe this thing can also just dump strings from the binary too. I'm going to go ahead and guess that it's Z. We'll see what happens. Okay, so that's probably like the string count or something. Let me try lowercase z. So there we go. So this dumped the strings from the data section only, data sections. So let's see if I do, see what happens if I do ZZ. Okay, so it is -ZZ. So it's basically the same command you would use in Radare, but it's outside of Radare. And this gives us all the strings in the binary. Okay, so if you just want to do some basic recon on this thing, that's one way to do it. Now, the second thing I'm going to show you, the second utility that I'm going to show you is called rafind2. So we're going to do man rafind2. And what this thing does is it finds byte patterns in files. But it also essentially, it'll allow you to search for strings. So let's say a use case for this is you just wrote a program, or your company wrote a program, and you are trying to see which strings you guys have left in your program. Did you leave secrets in there? Did you leave keys you shouldn't have left in there? Do you want to see what a reverse engineer can find out about your program by running strings on it? So the reason why this is useful is because if you just try to grep something, you're not going to get all the strings in a binary file that you would like. So just as a practical example here, I'm going to clear the screen. I could do grep dot slash letter frequencies. I can't remember if when you do it like this, you have to put the term after. Okay, so the term goes before. Right, so the word test doesn't appear in there. So printf, it does appear in there. There is a printf in there, but it's not really. Grep is not really made to search through binary files. So the good thing about rafind is that it's made to search through binary files, and so it does a better job at locating things. Now, what you would usually want to do inside of Linux, at least, or even on Windows, is you could run the strings command. So you could basically do strings dot slash letter frequencies, and then you could pipe that to grep, and then you could look for printf, right? And now it's going to show you that the printf. So maybe you want to look for secret. There is no secret in there, by the way. But so that's useful, but I believe by default strings is only going to find you ASCII strings, and this rafind has a lot more customizations you can make. And additionally, rafind is probably better to use if you need to analyze a whole bunch of different files. Just run them through rafind rather than having to run it through several different programs like this. So back to the man page here one more time. Let's see what we can do. So -z searches for all zero terminated strings. -a is useful because it only accepts aligned hits. So for example, let's say you want to find strings that are only at a memory address that are aligned to like 16 bytes. or 8 bytes or something like that. So you could specify -a and write that. So dash lowercase s search for a specific string. Dash uppercase s searches for a specific wide string. So you can do multiple different types of strings there. You could do regex with -e. You could so -i basically identifies the file type. So it's almost like running file on a file. You can carve files out of this. You could basically do a from and to address. So you could pick specific sections of a binary to search through rather than through the entire binary, even though it does the whole binary by default. So there's a lot of stuff you could do, but let's just go and do RA find to dash lowercase s printf dot slash letter frequencies. So what it does is it spits out the addresses of where those things are. So now you could go into like Radare and look at these addresses and you'd see where it was. Let's see if we can find anything else. No glibc. There's libc though. So libc occurs at these specific addresses. And what you could do is you could do a little bit of command line foo, and the creator of Radare wrote a little article that shows you how you could basically just use bash scripting and write a for loop and loop through every single one of these addresses, and then use the Radare API or the command interface basically, and essentially display everything too, and get like a hex view. In fact, I'll see if I actually have the command here that I could show you really quick. So how you could do that, just to give you a little bonus here. So I'm going to start up Vim real quick, and then I'm just going to paste. Oops, not what I want to do. Okay, I want to paste it here. So that with a command simple as this. So let's say you wanted to analyze bin ls. You basically whatever binary you want to put. Whatever binary you try to search, so in our case this would be letter frequencies. So then you're just going to say for address in RA find -s whatever you're looking for. So in our case it would be like, libc. Then it is going to run that against our binary, and then it's going to send that data to Radare2, and it's going to tell it to give us an output of hex basically. And when this is done, what happens is it gets displayed all nicely in your terminal, and it shows you not only where the data is, but it actually shows you the data. So if you want this, I'll put the link in the description. It's pretty straightforward. So I'm going to go ahead and exit out of this now without saving. And so let's do a search now for. I don't think I have any wide strings in here, but we'll just do a wide string search as well. Yeah, I don't have any wide strings for that. But so this is really good for basically searching through binaries, looking for specific strings, looking for regex, trying to find any secrets or any other information that you may have left, accidentally left inside of the binary. So you could actually, I think you can get a list of strings from this too, but you could also get a list of strings from the previous program. So there are some overlaps between some of these utilities, and the idea is that you can do most or all of these things inside of Radare as well. These are basically individual front ends to the different libraries that Radare uses in its main program. So that's what I wanted to show you today. And let me take a look at what's going on next here. So the next thing we'll do is talk about patching a binary. So we'll go back into main Radare and we'll look at how to do that. And then I'll also show you how to parse a header in Radare, which is actually pretty cool to do. So that will essentially, I'll show you right now actually, because it's kind of related here. So what I'm going to do is do R2-NN /letter frequencies, and then you do dash that in because what that does is it basically loads up these header structures and applies them to the file. And so what I mean by that is now if we hit Shift V and enter back into our visual mode and we go to visual mode here, you can see that there's the ELF header here and the ELF P header. So that basically parsed that data for us. So I'm going to hit Q to go back now. And then in order to actually look at these headers, like you might do like a hex editor, like O&O editor or something, you could actually use the PF command. So if you do PF dot, see it is showing me some of these that are available. And then what I can do here, see there's the ELF SH, the ELF S header, P header, and then the actual ELF header here. So, and it shows you like which members are actually available. So if you want to actually parse that out so that it looks nicer, we could do pf.elf header and then @elf header. So if you think about what's going on here, it's basically parsing the format, with this struct, the ELF header struct, at this memory address. And so if we hit enter here, there you go. You have a nice clean looking version of those items from the ELF header. So again, if I go back to visual mode and take a look at what's going on here, you can see that this is the very beginning of the file. The first thing that's there obviously is the ELF header. And so when we're saying @elf header, we're saying this symbol right here. So that's all for this video. In the next video, I will cover some of that other stuff back in Radare. We're going to start working with patching binaries. So thanks for watching, and if you like this, don't forget to subscribe.